Hello everyone, welcome to my YouTube channel Data Partnership. So today video is continuation of my groundwater series. So I started from data source. One of the data source means how to download the time series data, and then um, I created few videos on groundwater regulations, basically guidelines, and then uh, how what will be the report format and some data means from specification of means flow meters and all. So now since I'm talking about data, I have downloaded some. I also showed you from where you can download the data. So I just trying to show you what I'm doing, and you can do from that data. Since it's a large set of data, so I showed you in my previous video that it was these are very big PDF files like pre-monsoons series season. I have three decadal files based in 1994 to 2003, then 2004 to 13, and then 14 to 2024. So it's a huge data set, right? So and very useful. You can do any kind of study, trend analysis, or whatever you want to do, right? So I'm also trying to do something based on this data. I tried it, and I'm sure that you guys are taking benefit of these videos, right? So I'm not the basically I'm not the developer, or I'm not the programming guy, but I'm trying to learn from I'm and giving you those codes so that you can also get help, and you can start from somewhere and improve the things, right? So this is I have done in my previous video. You can check. I will share the link of that video in the description box. So this is it comes like this, and we did some statistics, right? And then we have these point we have created geodata frame, right? And we plotted those points here, special distribution of groundwater depth, right? And then we have classified all the depth in basically in the pre-monsoon season. So I'm talking about pre-monsoon because we have more data. Monsoon and winter season data is also available, since we have four seasons, right? I showed you in my previous presentation that we have four seasons. Post rabi withdrawal is January, pre-monsoon March, April, May, monsoon August, and post-monsoon November. So right now we are talking about this, right? Pre-monsoon. And this was the we I showed you that how it looks like, right? I showed you that how it looks like the data in the PDF files, right? And then I converted that PDF into CSV. So today yeah, so basically I'm talking about this period, right? And then I tried to show this data in a heat map. I created that so that you can see the stress level. And so now today what I'm going to do is basically trend analysis. What are the trend since it's 1994 to 2024? So you can see it's around 30 years data. So how you can do lot on this data. Of course, people are I'm sure that people are using that data and doing a lot of stuff, because nowadays lots of areas are water stressed, and everybody everywhere water is one of the topic at at a higher level. Everybody is talking about about water risk and water security, right? So that's why this is very important. So so what we are doing is so basically linear regression, and this what is the statistical significance and a special trends map, whether it is the positive or negative, means it's a rising water table or falling water table. So if it is positive, means if slopes are positive, then linear regression means slope. Then it means groundwater declining means deeper water table. And if it is negative, then water table rising. So p value is less than 0.05, trend is statistically significant. So similarly, yeah. So so what I did is that This is my data. I did something means date and we coerce the date column. So basically we have created one more column, date parse. I have already done that before, but it is very difficult to handle a lot of data. So I thought that better to do it again. So I have created one more here. It is already there in my previous sheet. If you see here, uh, already here in the date pass, and here I have done already, but I wanted to do step by step, otherwise I will also confuse. So based on that, then I have used sciencepy.stat Python library. So it imports linear regression like this, and then based on that, I have defined the those latitude, longitude, and all the trend list, like slope. You can see p values, r value, n value, n years, right? Like that. So here few terms ilog we have mentioned here. So I will show you that. I will create a separate video of ilog. It's a very important part of Python. So based on that, what we got this kind of table, right? For where we have latitude, longitude, slope, p value, r value, means all the parameter we are discussing above, right? So we have district, block, and village level informations, right? So then we have classified this data, means all the trained value we have. If p value greater than 0.05, greater than this, then no significant trend. If it is less than, if it is greater than 0, then we can say that it's a declining water level, otherwise improving water level. So we set uh, the DTWL, right? Means the p value we have set. So based on the some certain criteria, we can like this. If slope is like okay, so so we got this kind of this table. So if you see the row first, so what is there is slope is 0 minus 0.485, means groundwater is improving, means minus means improving 0.48 meter per year, right? If slope is plus 4.5 times, you can see 4.59 here. So it means that the water level is declining by this 4.6 meter per year. But sometimes we have to see how many years we are taking sample. Sometimes it is in this case is 6, means the small sample. If it is 30, then it's a big sample. So p value 0.11 means not statistically significant. So it all depends on, it's not the only criteria, I can tell you, because there are lots of other parameters. I am just showing that these in a simpler way we can do this, right? So then p value means I already defined that in this row. If p value 0 point some this, and then what is there, then p is highly significant. And if p is this one, then no trend at all. If it is like this, then so based on this criteria we have, uh, means this table we can interpret like this, right? Then r value means what is the strength of, what is the correlation about this. Plus one means perfect upward trend. If minus one is perfect downward trends, and near zero no trends. And so similarly we have those. So you can see in my this table, right? So what is the important thing then? It's a big data. So I have exported this file, this analysis, into a shape file. So this is first we have created this df and this data frame into the geo data frame by using GeoPandas and safely. Then you can write this code. And so we have gdf underscore train to file gw train dot shp. So we have run this, then we got this is my file. So you can see this one, right? So this one we got, right? So we have those points, but every point has those 30 years data. So now based on that, you can see if I click right click here, so you can see we have latitude, longitude. For this is the one location, we have slope, p value, r value, n year means sample layers 26, and all the district, you can see it, state and districts, right? So you can train classes at that particular position is you can improving water level, no significant trend. So you can based on this table you can draw a lot of analysis or lot of assumptions. You based on this you can do that. So this is what I want, and you can see we have these blocks, this category block means this one you can see we have critical, and we have critical blocks also. We have over exploited, safe, and we have saline or semi critical. This I already discussing many places. It's a 2020, but of course there is 2024 also. So I will show you that in later stage because I need to do some work on that. So basically, so what I'm trying to tell you that you can draw a lot of conclusion out of it, right? No means assumptions, so that you can assess the water risk, and you can do the hydrogeological study. A lot of water related study you can do, and of course this is not the only criteria. There are many other analysis you can do, because I'm not the statistical guy, so I'm just whatever I'm learning I'm just sharing with you. This is my objective here. So based on this you can also, what you can do is you can symbolize this, categorize uh, uh, based on the trend, right? So here we can classify like this, right? So yeah, so you can see here that if it is red means declining water level, and if it is green then improving water level. If it is this purple, no significant trends, right? So so this is we need to check that how things are moving and how what else we can do. And also you can compare this with the categorize of the, if trend is there, if declining water table is red, it means it should come under the this this the block where which is the critical. So you can see here, here is a red dot is here, it means declining water table, and this block is also in the over exploited area, and we have no significant trend, and as well and improving water. There are some point where water level is improving, maybe there are some interventions done by the certain authorities, right? So this is what I wanted to show you, and of course I am going to do a lot of work on this, and I will, whatever I will do I will share with you also. I will do other season data also. This is pre-monsoon, and I hope it will helpful for you and for your own research. And you know please work on this and those codes and whatever you can do. And you can also create a database in SQLite. It's a big database, so I'm also trying to do that, so that this basically how we can use this data for the decision making. We can develop a decision support systems. Yeah, thank you very much. Thank you.